So in this video, we're going to look at parallel lines and perpendicular lines through the y-intercept and slope lens. Now, parallel and perpendicular lines are an important part of geometry, and they have actually distinct characteristics that can help us identify when lines are parallel and when they're perpendicular. More specifically, we could actually take a series of points or equations and predict whether the lines are going to intersect or not. Graphically, when lines are parallel, they will never intersect. So if you look at these two lines over here, doesn't matter how long they go on for, they'll never intersect. Whereas perpendicular lines have a distinct point of intersection here, right? So right at the yellow point here. And if we know that point, well, there are algebraic ways to find that point of intersection. But the real question is, how could we tell from certain type of data, whether it be a relation or a table of values or a set of points, if lines are going to be parallel or perpendicular? So let's say we start off with a linear function over here as written in green, and we want to make a line that is parallel to it, or that is guaranteed to be parallel. Well, we can follow the following strategy. So the first thing we're going to do is we're going to make the equation of the line that we want to make a parallel line of. And so with this here, we have our y-intercept, or the b value, which is going to be equal to 1. And then what we're going to do is we're going to find the slope. And the rise over the run in this case is going to be 1 over 2, because we can see that it increases by 1 when we pick 2 points. And then it increases to the right by 2, so 1 over 2. So with the b value and the slope, that is going to be equal to y is equal to half x plus b, or in this case, plus 1. Now, why do we make the equation of the original line? Well, because one of the properties of parallel lines is that they have identical slopes, but a different y-intercept to the original line. So once we know the slope, and we know the y-intercept, we can then start to build our line based on those two values. So then the second point or step in the strategy that we're going to use is to pick any y-intercept and plot it. And it really can be any y-intercept. So let's say if this y-intercept is 1, I'll do a y-intercept of 3, and I'll put a dot over here. So then using the slope, or the m value of the original line, which would be the 1 over 2 here, plot 2 more points from the y-intercept. So from the green dot over here, I'm going to go up by 1, over by 2, and then plot 1 point here. And then from that point, up by 1, over by 2, and plot my second point here. Then you just connect the dots that you made in step 3, and then that's your line that is parallel to the original line, which in this case is this line over here, the one that we've highlighted. Now let's say we wanted to make a line that is perpendicular to this line over here in green. And what essentially that means is we're trying to create a line that intersects. Well, a lot of the process is going to be the same as that of the parallel lines, except we're going to look for different things. Now, the first thing we're going to do is make the equation of the line. And why? Well, because perpendicular lines have a slope that is the negative reciprocal of the original line. And I'm going to underline that word here, negative reciprocal. So let's say the original line has a slope of, let's say 1 over 2. Well, the slope of the line that is perpendicular, so I'm writing the perpendicular sign, that is going to be negative 2 over 1. So the reciprocal simply just means that this is flipped, and then we add a negative to it. So like I did with the previous example, I've identified the b value of the y-intercept, and over here it's going to be a 2. So I'm going to write b is equal to 2. And then, of course, we're going to get the slope of the line, and we can do that by picking any 2 points. It doesn't really matter where you start, but let's get the slope of the line so we can write the equation. So we see we have a rise of a run of 2 over 2, which is really equivalent to just 1. So our equation of the line for this one is y is equal to just x plus 2. Now you can write 1 over 1x, and that's fine if that's going to help you get the negative reciprocal, but it is redundant in math. You don't have to write the ones in. We could just leave it blank right beside the variable. So 1 over 1. So then the second part of this is going to be that from any y-intercept, you could really start it from anywhere along the y. We're going to create 3 points with the negative reciprocal. It can be 2, but usually they say the best thing to do is 3. But if you want to just do 2 points from that y-intercept, that is totally fine. And so over here, if our slope is 1 over 1 or 1, then our perpendicular equation is going to be negative 1 over 1. Or we could just write negative 1x, or even just negative x. I'm going to write negative 1 over 1x plus, let's say we wanted to start this from, we could have started from, remember we can start from plus 3. Even if we kept it the same, that's fine. So we write negative 1 over 1x plus 3. Or we can write y is equal to negative x plus 3. And then once we have our 3 points, all we're going to do is just connect the dots. And so each point, again, was plotted from a y-intercept of 3 here. And so let's say I plot my points and I draw a straight line through them. I could see that it does actually cross right over here from the green line. And so therefore, this is clearly a perpendicular line. And so to sum it up, the first thing you're going to do is get your equation of the line so that you understand the slope. Once you have the slope from any y-intercept, you can do it from the same y-intercept, and that's totally fine, or you can choose a different one. But from any y-intercept, create 3 points with the negative reciprocal of the slope. So if your slope was 1 over 2, it's now going to be negative 2 over 1. If it was 1 over 1, it'll be negative 1 over 1. And once we do that, just like we did over here, you connect the dots, and you should see that if you extend your line long enough, it will intersect with the original line. Hence, it is a perpendicular line.